Hello, welcome students. I am Rekha Thorat, Associate Professor. Today we will study case 5 where the in particular integral operating factor is of the form x into phi, where phi is function of x. Particular integral equal to 1 upon fd operated on x into phi. Now derivative of x into phi equal to, here we use product rule, x into derivative of phi plus phi into derivative of x is 1. Now we take second derivative of xv, that is d square of xv equal to d of x d of phi plus phi, that is d of xv, but d of xv is x d of phi plus phi equal to x d square of phi plus 2d of phi. Similarly, d square of xv equal to x d cube of phi plus 3d square of phi. Continuing in this way, we get d raised to n of xv equal to x d raised to n of phi plus n d raised to n minus 1 of phi. Thus, d raised to n of xv equal to x d raised to n of phi plus d by dt of d raised to n of phi. In general, we get fd of xv equal to x fd of phi plus f dash d of phi. Now we put fd of phi equal to phi 1. So we get phi equal to 1 upon fd operated on phi 1. Hence fd of phi equal to 1 upon fd operated on phi 1 equal to x phi 1 plus f dash d 1 upon fd operated on phi 1. Hence x phi 1 equal to fd into bracket x 1 upon fd operated on phi 1 minus this 1 upon fd 1 minus f dash d into 1 upon fd operated on phi. That means this term is taken on this LHS side so that it becomes negative, and then we replace left hand side and right hand side. Now we operate both sides by 1 upon fd, so that we get 1 upon fd operated on x phi 1 equal to x 1 upon fd operated on phi 1 minus 1 upon fd operated on f dash d into 1 upon fd operated on phi 1. That means we have operated 1 upon fd on both sides. So we get 1 upon fd operated on x phi 1 equal to x minus 1 upon fd into f dash d in bracket complete into 1 upon fd operated on phi 1. That means this term is taken common from both these terms. So we get finally formula as 1 upon fd operated on x phi 1 or x phi equal to in bracket x minus 1 upon fd f dash d bracket complete into 1 upon fd operated on phi 1 or 1 upon fd operated on phi as the term. This is the final formula. Now we consider some examples. Consider first example. Solve d square minus 2d plus 1 in bracket operated on y equal to x e raised to x sin x. First we write given equation in this solution. Here auxiliary equation is d square minus 2d plus 1 equal to 0, that is d minus 1 in bracket square equal to 0. So we get d equal to 1, d equal to 1. So that complementary function is c1 plus c2x in bracket into e raised to x. Now we consider particular integral. Particular integral equal to 1 upon in bracket d minus 1 bracket square operated on this x e raised to x sin x, which is equal to e raised to x into x sin x, that is of the form x into phi. And here x into sin x is of the form e raised to ax into phi. So we take e raised to x here and coefficient of x is 1. So we put d equal to d plus 1. D equal to d plus 1 minus 1 bracket square operated on x sin x. Hence, particular integral equal to e raised to x 1 upon d square operated on x sin x equal to e raised to x. X minus 1 upon d square. Here we use the formula for x into v. 1 upon fd operated on x into v. That is x minus 1 upon fd, that is 1 upon d square into f dash d. Derivative of d square is 2d, bracket complete, into 1 upon fd, that is 1 upon d square operated on phi1. That is phi1 means x into phi, that is sin x. But 1 upon d square sin of x equal to 1 upon d sin of x equal to 1 upon d means integration of sin of x equal to 1 upon d operated on minus cos x. 1 upon d means integration of minus cos x is minus sin x. So we get here minus sin x. Now it is operate this minus sin x on this bracket. So we get e raised to x into bracket minus x sin x minus 2 into derivative of minus sin x is minus cos x, that is 2 into minus sin x into derivative of sin x, that is 2 as it is derivative of integration of sin x. 1 upon d means integration. To derivative of sin x, 2 into d upon d square, that means 2 upon d. And means 2 minus minus plus 2 1 upon d of sin x, that is integration of sin x is minus cos x, bracket complete. Here we take minus sign outside, so we get particular integral equal to minus e raised to x into bracket x sin x plus cos x. But y equal to cf plus pi is complete solution of given equation. Hence y equal to in bracket c1 plus c2x bracket complete into e raised to x minus e raised to x into bracket x sin x plus cos x bracket complete is the complete solution of given equation. Thus, here we have seen first the formula for the operating factor x into phi, where phi is function of x. That means when the particular integral equal to 1 upon fd operated on xv, we take derivative of xv and we then find in general formula for d raised to n of xv. Here we take first derivative of xv, then we take second derivative. Here only we used formula is product rule. Take the differentiation using product rule, we get here x d square of v plus 2 derivative of v. Continuing in this way, we get d raised to n of xv equal to x d raised to n of v plus, this can be written as d by dt of d raised to n of v. So in general, we then operate fd, so that fd of xv equal to x fd of v plus here f dash d of v, since here derivative occurs. Now we put fd of phi equal to phi1. So we get phi equal to 1 upon fd operated on phi. So fd into x into phi equal to fd into bracket x into phi. Phi is 1 upon fd operated on phi1 bracket complete equal to x into phi1. Phi1 means x into phi1 as it is plus f dash d into phi, but phi means 1 upon f d operated on phi1. We put first term as it is x phi1 on the RHS, that is f d of x phi equal to x f d of phi plus f dash d of phi. We keep this term as it is and replace phi here. So we get this term. Then we obtain x into phi1 equal to this LHS term minus this f dash d into 1 upon f d operated on phi1. Then we operate on both sides by 1 upon f d of both sides of this term. So 1 upon f d of x phi1 equal to 1 upon f d of whole this term. 1 upon f d, 1 upon f d into f d cancels with each other as they are reciprocal. We get only this bracket x into 1 upon f d operated on phi1 minus 1 upon f d of this term, that is f dash d into 1 upon f d operated on phi1. So we get finally formula as 1 upon f d operated on x into phi1 equal to in bracket x minus 1 upon f d into f dash d bracket complete into 1 upon f d operated on phi 1. If there is phi, then here is operating factor is phi. So sometimes this formula can be asked for objective as 1 upon f d operated on x into phi equal to dash dash equal to x in bracket x minus 1 upon f d into f dash d operated on f dash d bracket complete into 1 upon f d operated on phi if x into phi is operating factor. Then we consider one example, that is d square minus 2d plus 1 in bracket into y equal to x e raised to x sin x. Here we take auxiliary equation as d square minus 2d plus 1 equal to 0, that is d minus 1 bracket square equal to 0. So we get factors as 1 1 which are repeated. So we get complementary function as c1 plus c2x in bracket complete into e raised to x. Then we consider particular integral. Particular integral equal to 1 upon d minus 1 bracket square operated on x into e raised to x sin x. But it can be considered as e raised to x into x sin x, that is e raised to ax into phi. So that we take e raised to x into 1 upon, replace x d by d plus 1 since coefficient of x is 1. 1 upon d plus 1 minus 1 bracket square operated on x into sin x. We have used here formula particular integral 1 upon f d operated on e raised to ax into phi. Phi is x sin x. So we get this term e raised to ax into 1 upon d plus a for d and remaining term as it is operated on phi. Phi is x sin x. After simplifying we get e raised to x 1 upon d square x sin x equal to e raised to x. Now we use the formula we have studied, 1 upon f d operated on x phi. Phi is or phi1 is sin x. So we get x e raised to x into bracket x minus 1 upon f d, 1 upon d square, and derivative f dash d means derivative of d square is 2d bracket complete into 1 upon f d means 1 upon d square operated on phi1. Phi1 means sin x. We have calculated 1 upon d square of sin x is minus sin x. Then we operate this term in bracket and finally we get, after minus 1 taking common, we get pi equal to minus e raised to x into bracket x sin x plus cos x. But y equal to cf plus pi is complete solution of given equation. So we get solution of this equation as y equal to in bracket c1 plus c2x bracket complete into e raised to x minus this pi, that is minus e raised to x into bracket x sin x plus cos x bracket complete. This is the complete solution of the equation d square minus 2d plus 1 in bracket into y equal to x e raised to x sin x. So we have obtained the complete solution of given equation. Thank you.